preliminary results. So the framework, the syntactic framework in which the study is situated is the Valency Theory, in which some elements of the sentence are determined by the verb, either in terms of the form or by their presence. So if we look at these two sentences, it becomes quickly visible that in the first case, it is the presence that is determined by the verb, the presence of these two complement slots. And in the second case, it is the form of the complement slot that is determined by the predicate. And on the other hand, there are some purely optional elements called adjuncts, which basically fall outside this predictable nucleus of the predicate. So surprisingly, there is not that much attention paid to this fundamental distinction in the theory of syntax on the level of processing. And on the one hand, this is remarkable given the amount of research in the theoretical field. But on the other hand, it's probably not that much surprising because there is a consensus among linguists about the problematic character of the distinction, even on a more theoretical level. So basically, problems arise at the point when complements are confused with adjuncts, because not all complements are obligatory. So there are basically no sufficient criteria to operationalize the distinction. Herbst and Schüller, for example, offer the deletion test, according to which if you take out the slot from the sentence and the sentence is still grammatical, then this has been an adjunct. On the other hand, you may have sentences like he sings songs to his children. So if you take out to his children, the sentence is still grammatical, but I think we can all agree that there is a strong association between singing and to whom you sing. So that's why it sometimes makes more sense to talk about free addability rather than deletion. Dowty then takes a dual approach to the distinction, and he basically says that every adjunct is a complement and every complement is an adjunct, meaning that when, for example, non-native speakers of the language try to comprehend a sentence, that then the first step would be the adjunct kind of analysis. And then if the meaning turns out to be idiosyncratic, then reanalysis would happen in terms of the complement kind of analysis. Sommers rejects the binary distinction, and he says that basically there is a gradient between the two endpoints, so it's a 6-unit scale. And finally, basically all linguists, well, at least recently, tend to agree about the gradient character of these two phenomena. So, but if we move away from the operational distinction, and then if we turn to real language uses, so what is how valid is the psychological distinction? What happens in the mind? Does this predictability result in advantages in processing for the complements? So as far as the evidence in literature is concerned, it's really limited. So going back to Dowty, if what he says or if what he claims is true and the adjunct kind of analysis is indeed the preliminary step, then it would be logical to assume that adjuncts will be processed faster than complements. The study by Ricard, Günther, and Sicherschmidt probably comes the closest to the question of the impact of the semantic information of the verb on its arguments. So they've done a study on the verb first, verb last positions in trivial constructions in German, and what they found out is that the verb in the verb last position was processed significantly longer than the same verb in the verb first position. So here you basically see one and the same sentence. German allows for that, so you have verb in the first position, here in the last position. And then what is probably more interesting is that they haven't found any significant differences for the arguments in the middle of the sentence. So basically, you would expect that when the verb is introduced in the verb first position, then this would be something like a prediction for the upcoming slots, which was not the case according to their results of their study. So it basically would be more interesting to know whether this predictability or whether this encoded semantic information impacts in some way the following complement or the following adjunct. So I'm particularly interested in these pair of sentences. So the mother went to search for cigarettes in her son's room, and we can only search with permission on private land. So in the first case, you have a complement here, and in the second case, it's an adjunct. So that's why the two research questions that initiated the study were if complements are processed faster than adjuncts because of that predictability that is inherent in verbs. And the second one, if this is true, if this advantage in processing is associated with language proficiency in non-native speakers, and that's the population I was working with. So the reasoning behind it is simply that more advanced learners would be more familiar with this item-specific information, and that's why they would benefit the most for this gap between the processing of complement and adjunct. Now, probably the most reasonable and the most popular way to do so would be to design an eye tracking experiment where you would have a kind of a natural setting, to have the items embedded in sentences. But as we know, the price for such experiments is quite high, so the costs are high. This includes the equipment, the laboratory costs, specialists, etc. So in this study, I've tried to design a method that would resemble, let's say, the eye tracking methodology, but would be, with little cost. That's how I've come up with this method, the mouse-controlled reading. And I would first demonstrate it, and then I will comment on it. So the participant would basically read through the sentence by moving the mouse from left to right, in case of English. Right. So what are the features of the task? So it resembles the self-paced reading task, but backtracking is possible, so you can go back as many times as you want. The preference will be for using a wireless mouse, not the touchpad or not a trackpad, because basically if you do that with a touchpad, then the movement would be limited to a small space, which would not be a natural, or which would be less natural, let's say. Also, there was limited visibility. So again, if you do, if you make a parallel with the eye tracking methodology, you would normally see the whole text, and then the software would simply record your movements, the eye movements, whereas here it was all limited to a small diameter, 5 characters to the left and to the right from the fixation. But still, we think, or I think, that it's expected to track the reading flow. Importantly, the lines, the sentences should be presented on one line. That's how you would make sure that they don't spend more time on, changing their, doing this movement from line 1 to line 2. And the attention was controlled through a grammaticality judgment task. So basically, the expected pluses are that, this is a, more or less natural reading. I mean, if you compare that with the self-paced reading task, you wouldn't have to press the, let's say, the space button to proceed through the task. You just need to move the mouse. The items are embedded, they are not in isolation. Theoretically, first, second passes are possible, so you can really measure how much time a participant spent reading something for the first time, and then if the participant went back to the same item and read it again. However, in this study, I only measured, yes, the aggregated, I only recorded the aggregated measures. What are the expected minuses? So I think we could all agree that mouse movements are not always equal to reading, in the sense that it might be possible that the participant would be frantically moving the mouse, trying to locate it on the screen. But still, this can be overcome. If you just read the output, it will be visible where the XY coordinates are, and then you would know whether this is approximately on the level where your sentences are or not. What is probably more important is that the span that we had, or that I had, was less than the perceptual span and then the letter identification span, but it was just right as far as the visual span is concerned. So in a task like this, you would expect to have okay, so first of all, as I said, this is a pilot study, so it had a within participant design. In this study, I'm going to report the results of 10 participants who were German native speakers. So they went through a personal background questionnaire, the MCR task, and also the C-test was used as a measure of language proficiency. What I measured was the XY coordinates, the timestamps, and the C-test scores. So the MCR task, let me tell you something behind the construction. So it has 15 complement adjunct pairs and 20 ungrammatical fillers for the grammaticality judgment task. What is important is that only the target items were controlled for length and frequency, not the whole sentences, and they were counterbalanced to avoid priming. Because if you remember the pair that I showed previously, the verbs were always the same and they were in the same word form. And also they appeared in the middle to avoid a wrap-up effect or similar things. And you would expect that in a task like this, there will be a lot of noise from the human hand movements. So that's why what was important to do is data filtering. So you would imagine that you are reading a sentence by moving the mouse. So once you reach the end of the sentence, you would have to indicate whether yes or no, whether it's grammatical or not. And then you would have to drag the mouse back to the sentence initial position. So to make sure that this dragging back movement was not added up to the next trial, they were manually removed. And then at step 2, which was automated, all the basically all the regions outside the target region, so outside the complements and adjuncts, were also filtered out because they were not controlled for length and frequency. And finally, the C test. So as I said, it was used as a measure of general language proficiency. Here in the box, you can see an example, a fragment from the task. So basically, you would have, at every second word, you would have the second half missing. And the idea behind it is that it's based on the reduced redundancy principle, according to which advanced learners should be able to deal with this kind of redundancy. And here are the preliminary results, and probably so far all I have. So here we can see the data plotted from the hand movements of 10 participants. On the left, you have complements. On the right, you have adjuncts. So these are density plots. So they don't directly tell you the time or how much time the participants spent reading certain items, but they can be directly translated into time. So basically, the software recorded the mouse movement or the mouse position at every 60 or 17 milliseconds. So the graphs then would show how often the participant landed at a certain point. Speaking about the means, there was approximately 300 milliseconds difference between the person of complements and adjuncts in favor of complements, so they were processed shorter. And then I use a linear mixed effects model to analyze the data. Well, this kind of model was used to control for variability in items and in participants. Unfortunately, no significant effects have been found, apart from the significant association between reading times and the response, in the sense that the more correct answers they gave, the participants gave in their grammaticality judgment task, the shorter their reading times, which is logical. And well, obviously there has been not enough statistical power. In spite of the results, I am certainly still going to continue the study, and to explain the reason, we'll have to go back to the graphs. So I think when we look at these two graphs, we could agree that there is quite a certain amount of alignment or agreement between the behaviors of the participants generally, and also in the two different conditions. I think we could agree that if we take complements, for example, then in this condition, there is even more agreement. So that's the first point. And secondly, which, by the way, would probably prove that there is a certain kind of formal predictability factor that is encoded in complements. And secondly, if we look at the complement graph again, then we can see that the beginning of that graph has a shallower slope, which might be connected to the fact that the majority of the items, 13 out of 15, started with prepositions, which are very strongly associated with verbs on a formal level. So what are the next steps that I'm going to take? First of all, recruit further participants to reach statistical power. Second, to verify the method. First, a different method would be used for the same phenomena. So I'm going to use an SLP's reading task, which is an established method with the same sentences, with the same trials, to see whether it was a problem about the phenomena or it was a problem about the method. And then also I'm going to use different phenomena with the same method, so something that is more established in psycholinguistic research, again, to check the validity of the method. So far, this is all I have, and I will be happy to hear your questions or comments.